Next package that we are going to learn today is Pandas. So Pandas is a Python library that helps us to work with data, a huge amount of data. Maybe it can be structured data or time series data. So structured data, that means like which we see in table or something like that. We can consider Pandas as Excel for Python, and it can hold all the data that can be computed in Excel. Together with that, we can also compute many other forms of data. So the primary information that we want to work with Pandas is series. So series, that is the one of the data structure in Pandas, and another one is data frame. So we will go through each of them and we'll know how to use each of them. So similar to NumPy, we will first import the Pandas as PD. You can also import just Pandas, but when it's a normal practice to import Pandas as PD, but it is equally okay if you just import it as import Pandas. But you have to know everywhere in this notebook we will have to type Pandas instead of PD. But for now, let's import Pandas as PD, and also let's import NumPy as NumPy. So first data structure in Pandas is series. What is series? So series, you can consider it as same as the array that we discussed in NumPy. So only thing that is different from NumPy array is that series can have its own axis labels. That means in NumPy, array were only indexed based on their numbers, like okay, the array with index 0 or index 1, index 2. But in series, what we can do is we can select certain object inside a series using the name of its axis also, and together with its index. Let's see how. Let's first create a series. So we will just have simple list of labels ABC and list with values 10, 20, 30, and then a NumPy array of the same list, and then also one dictionary. So dictionary has a key and value pair. Okay, now let's create the series using list. So we can just create a series using pd.series, and then it will show the output something like this. So that means our list is we have loaded our list, my list 10, 20, 30 as a Pandas series. So 10, 20, 30 is loaded as a series, and 0, 1, 2 is the index of these objects, and the type of the objects is integer. Similarly, we can also add the index to the series. Let's see. Right now, right in this cell, when we load my list as data, so we have loaded 10, 20 and 30, and the index is 0, 1 and 2, but we can give index by our own. Let's see, now we have given the labels as index of the series. So it is not necessary that the index will always be 0, 1 or 2 in Pandas series. So we can now give the name to the index as well. So similarly, we can create like this with the index ABC, or index ABC that is defined in the labels and the values in the list. So if we want to use NumPy array, then also it's exactly the same. You will call using pd.series, and for dictionary also we will call pd.d. But you have to be careful, like when we load a Pandas series with dictionary, the key part will go as a index. So if you check our dictionary, D has key A and value 10, B 20, C 30. So this also the index will be A and the value will be 10. And Pandas series can hold multiple type of objects, so it is not necessary that we should only keep integer or float values only. We can also keep some objects, like in this case we have loaded the Pandas series with string, or there can be a JSON item or anything that we can imagine of. So it can have multiple types. And to use the index, we can add series and add index, like we have added labels. It's the same thing. So now the index is 2019, 2020, 2021 and the value is this. So this is just to show different types of methods how we can create a series. And then if we want to access some values in the series, we can just call the index. Let's see, in this case the index 22 has the value 4, so this will return the value 4. So we will go through some of the operations in Pandas series. Okay, so we have already defined a series 1 which has 3, 4, 5 according to the year as index. So we will also define a new series called series 2 with new years as the index. And then if we add these two values, we can add two series. So if you see now, right now what happens is, okay, series 1 has values for value for 2019, 2020 and 2021, and for series 2 it only has values from 2017, 18 and 19. So when we add series 1 and series 2, what happens is it only finds the common index as 2019, so it will add only 6, and for other values it did not find the common index, so it will return as NaN. NaN is also read as not a number. It's like a null value or any undefined value. But let's see, if we add this to be 2017, 2018 and 2019, let's change series 1. So now it has 17, 18, 19, and we add series 1 and series 2. Now it will display the sum of the numbers according to their index. So if we want to give name to this particular series, so right now you see there is an index, there is value, and then there is the type of data. If you want to give the name to the index, we can write name keyword and then give the name. So it will return something like, okay, name is product A, the type of data in this series is integer, and these are the data inside the series. Okay, next type of data frame, next type of data structure in Pandas is data frame. So you can consider data frame as a table. So it's pretty easy. Data frame is a table, and series is let's say series is just a column in a table. So if we combine multiple series into one, then it will become a data frame or a table. So let's see how we can create a data frame. So similar to series, we can create data frame just using pd.dataframe. So if we run this command pd.dataframe, and then we call the dictionary s and the list, no and the list. That means yes and no will be the name of the columns, and the values 50 and 20 will be the values inside that column, and no will be another column, and 100 and 200 will be the values inside this command. And if we want to name the index, so by default the index starts with 0, but 0 and 1, but if we want to name the index 2, then we can add something like, okay, index and array1, array2. Okay, so now you can see this is a data frame with index array1 and array2 with columns yes and no. Okay, now we will explore through another method of creating a data frame. So let's start a let's create an array with random values. On the size of array is 5 into 4. You can see the code here, np.random.seed. What does this do is, if you put the same seed, let's say right now I have used 42, so if you put 42 as well, so it will generate the same numbers in your computer and my computer as well. So this is the random values array that we created of size 5 into 4. So let's try to fill in the data here. So let's go through this command one by one. So pd data frame and random values. Now we are feeding the values in the table, and the index are Thailand, Malaysia, Japan, Laos and Vietnam, and the name of the columns are, so the name of the columns should be 4. So Dell, Samsung, Apple and HP. Let's run this code and let's see what's in df in our data frame. So now you can see these values for column Dell, Samsung, Apple, HP and for index. So this is how we can create a data frame in Pandas. So let's move on to selection and indexing. So how we can select the data from the data frame. Okay, so at first, okay, let's see. Right now our data frame df is defined as this table. So if we want to select a certain column, we can write df and the name of the column. So it will display only the first column here for an index that we have defined. Let's check what is the type of the column that we printed. So now you can see, so every column in data frame is a series. So data frame is like a table and every column in data frame is a Pandas series. So if we want to display multiple columns together, we can use the list of the name of the columns, something like this, Dell and HP. So it will only display the columns with Dell and HP. Or we can also use df dot name of the column, but this is not usually not recommended method. So if we want to create a new data frame, we can define it by the new name Apple plus Dell. Okay, Apple plus Dell equals to this is the new column how we can create. So instead of just adding two data frames, we can also add a numpy array as the values as well. So if we want to delete the column, we will use df the drop. Okay, let's see. Here we have used a parameter in place equals to true. Let's not use in place equals to true, just we will use false, which by default is false, and it says, okay, this column Apple plus Dell, drop Apple plus Dell column in axis 1. Axis 1 means in vertical axis, so it will drop the column from the table, and in place is set to false. What does in place does when it is set to false is like, okay, it will return then a new data frame with the column mentioned dropped. So if we check to the original one, so we still see Apple plus Dell column is still there. So in plus will just display the copy of the data frame with the column that we want to delete deleted. Okay, but if we say in place is true, that means now it will delete the column from the original data frame, that is df in our case right now. So let's check df. Okay, now we can see Apple plus Dell is deleted. So what if we want to delete a row, let's say, or data inside the table? So that means we have to say drop and the name of the index of the row that we want to delete, and the axis should be 0. You see here, while deleting a column, the axis is 1 is for vertical, and for horizontal the axis is 0. So if we drop Vietnam and axis 0, then it will remove the data with index Vietnam. Also, if you want to delete it permanently from the table, we will use in place here as well. Okay, so what if we want to select, now we know how to select a certain column, but what if we want to select certain row? So to select a certain row, we will use this function called LOC. We will use the function LOC and give the index. So df.loc Thailand. So you can see now it returned a new series with the columns as the index and their values. Or if we want to just display the data based on their index position, so for now, okay, we have mentioned Thailand as the index, but if we mention the position, okay, position 0, it should return again the same data. Now let's move on to the selection. How can we select using conditional selection? Our df right now, our data frame right now is this data, and let's say greater than data frame greater than 0. If we run this command, then it will display a new table with boolean values where the condition is success. It will show that where the condition is success or not. So let's say for this value for Thailand and Dale, the sales of Dale in Thailand is 0.49, which is greater than 0. That means it's true. But in Malaysia it's negative, so that is less than 0, so it's false. So what if we want to select the values that are only true? Then we can just use data frame, and inside the bracket we can give the condition. Let's see, now this will only select the values that are true, and for the false values it will add not a number or null values or unknown values. Or we can also select for only certain column. Okay, we will only display certain column with value greater than 0. So if you see our data frame, for Dale we only have greater than 0 for Thailand and Laos, so this will display only the data for Thailand and Laos. Similarly, we can combine multiple functions, right? For this command, let's see, what we did first is, okay, select the data frame for which value of Dale is greater than 0, and after this data frame we only selected Dale and HP from this. So basically what this does is, okay, this will create a view like something like this one above here, and it will only select the columns Dale and HP. So it will select Dale and HP. And if you want to add some more logic to it, we can also use the OR and AND with parentheses. So for this example, let's see, we want some only the data for which Dale, the value in the column Dale is greater than 0, and in Apple is greater than 0. Let's see our data. So what it should return is, okay, Dale greater than 0 and Apple is greater than 0. So it will only return the value for the index Thailand. So it only returns the value for index Thailand.